In this demo, we're going to take a look at trunking. This is a common term you'll hear when setting up or configuring enterprise networks. Essentially, when a port is trunked, that means its purpose is to transmit VLAN tags for Ethernet frames. Multiple VLANs will be able to pass through a trunk port. Switches have defaults applied to them out of the box, so we need to take a look at which defaults are set and what we need to change them to. On this switch, our VLAN settings will be under VLAN management. We're interested in interface settings. This will define all the settings for each switch port on the switch. If I select port number 1 and click Edit, I have many options to change for this single port. I know this may look intimidating, but the concept we're discussing today can be applied to almost any layer 2 or 3 managed switch. The default settings out of the box for all ports is trunk. Yes, this will work as is. However, most devices connecting to a switch only need an access VLAN mode. Data from a PC usually sends untagged Ethernet frames, but it can still be on a single VLAN in access mode. Previously, we set ports 1 to 26 to access mode with an untagged VLAN of 30. These ports will only be able to talk on VLAN 30, which is the VLAN of our main computer network. Ports 27 and 28 are the ones we're interested in, since they are our uplink ports. Both ports get the same VLANs assigned to them, since the same VLANs are on other switches in the network. In order to have a properly set up trunk port, we need to make sure the interface is in trunk mode and has the appropriate VLANs assigned to them. Let's select port 27 and click Edit. You can see there's multiple options for VLAN mode. Our port is already in trunk. However, a general port could work like a trunked port. The difference is general supports tagged and untagged members of one or more VLANs, while trunk only supports one untagged member of a VLAN and multiple tagged members of a VLAN. We're going to leave it as trunk and close it. Next, we're going to go to Port VLAN Membership. Here we can see which VLANs are assigned to which ports. As we scroll down, we can see our trunk VLANs have only the default VLAN assigned to them. When I select port 27 and click Join VLAN, this window here gives me the option to add more VLANs to this port. We want to add 30, 40, and 50, as we want all these VLANs to pass through this trunked uplink port. There's an untagged VLAN of 2 still on this port, but we're just going to leave that for now. Click Apply, and then close it. The same settings would be applied to port 28, just like we did with port 27. Don't forget to save your changes. Click on the flashing red button over here and click Apply, and then OK on the second window that pops up. Link aggregation is the process of combining multiple network ports together to increase throughput and provide a means of redundancy. Instead of just having an active-passive bond, we're able to utilize both network ports at the same time. In order to set up LACP, which stands for Link Aggregation Control Protocol, we have to add ports to a LAG, or Link Aggregation Group. To do this, we go to Port Management, Link Aggregation, and then LAG Management. We're going to select the first, LAG 1, and click the Edit button. Our name is going to be Windows Server. However, if you have a host name, that may be a better way to document the connection. Make sure the LACP checkbox is set to Enabled. Otherwise, it'll be grayed out once the LAG group is saved. Next, we're going to add port 1 and port 2, as these are the 2 ports I have my host plugged into. Now, click Apply and Close. It may take a short amount of time for the ports to reset themselves and for the host to pick up the new connection settings. The host has to be properly set up for LACP in order for this configuration to work. Normally, network engineers don't use the default VLAN on the switch for general network use. That being said, we're going to configure a new LAG group to another VLAN. First, we go to VLAN Management, and then Interface Settings. Change the filter from port to LAG and click Go. Our LAG 1 doesn't need to be set up as a trunk since a single VLAN will be going to our host. Now select Edit and switch the VLAN mode to Access. Click Apply and Close to exit the config window. Now that this is set, we're going to go to Port VLAN Membership and change the filter from port to LAG. Select LAG 1 and click Join VLAN. VLAN 1 untagged should be removed since we know our general network VLAN is 13. We're going to use that one. Click Apply and close the window. Keep in mind that VLANs other than the default will need to be created on the switch. Let's go back and check on the status of our LAG group. go to Port Management, Link Aggregation, and back to Lag Management. We can see our link state is up and we have 2 active members. This connection is now ready to use LACP. To save our changes, we're going to select the flashing red Save button, apply the running config to the startup config, and click OK on the pop-up window. That's it for this demo. In this demo, we configured link aggregation, created a lag group, and assigned a lag group to a VLAN.